In this picture, we can notice how my MacBook Pro laptop can form a right angle, thus generating a right triangle with an invisible hypotenuse. This triangle can be solved by using the trigonometric ratios we worked with in class: sine, cosine, tangent, and more. We already have two of the three sides of the triangle solved, as well as the right angle we already have. In order to find the other two angles and lengths of the sides left, we will need to use different trigonometric ratios. Now, to find the third side of the triangle, we will need to apply the Pythagorean theorem: a to the power of 2, b to the power of 2, c to the power of 2, so it would be 24 to the power of 2 plus 24 to the power of 2 equals c to the power of 2. c to the power of 2 would be 1152. And after simplifying the square root of 1152, side c now is 24 times the square root of 2. Now that we have all sides, we can proceed to find the two remaining angles. By using the inverse function sine, we can find the angle corresponding to side A. To do this, we write sine to the power of minus 1, so sine to the power of minus 1 opposite 24. So, to find the six trigonometric ratios of this triangle, we will need our calculator. The sine of A would be square root of 2 over 2. The cosine of A would be square root of 2 over 2. The tangent of A would be 1. The cosecant of A would be square root of the 2. The secant of A would be square root of 2. The cotangent of A would again be 1. The sine of C would be square root of 2 over 2. The cosine of C would be square root of 2 over 2. The tangent of C would be 1. The cosecant of C would be square root of 2. The cosecant of C would be square root of 2. The secant of C. The cotangent of C would again be 1.
In this picture, we can notice how a typical door in any common house can form a right angle, thus generating a right angle width. This triangle can be solved by using the trigonometric ratios we worked with in class: sine, cosine, tangent, and more. We already have two of three sides of the triangle solved, as well as the right angle we already have. In order to find the other two angles and lengths of the sides left, we will need to use different trigonometric ratios. Now, to find the third side of the triangle, we will need to apply the Pythagorean theorem. Now that we have all sides, we can proceed to find the two remaining angles. By using the inverse sine function, we can find the angle corresponding to side A. To do this, we write sin to a -1, and the answer given to us will be the measurement of the second angle. The answer of angle A would be 19.6 degrees. Now angle C, or the angle of elevation, would be 180 / 19.6 / 90. The two angles we already have. Angle C would measure 70.4 degrees. The sine of A would be 75 over 15 times square root of 221, so we need to rationalize. The cosine of A would give us a radical again, so the final answer would be 14 times square root of 221 divided by 221. The tangent of A would be 75 divided by 220, or 15 divided by 42. The cosecant of A would be square root of 221 over 5. The secant of A would be square root of 221 over 14, and the cotangent of A would be 210 over 75, or 42 over 50. The sine of C would be 14 times square root of 221 divided by 221. The cosine of C would be 5 times square root of 221 divided by 221.
Created using Powtoon.